Scientific notation is important when we're talking about measurement in science because it is basically a shortcut method of representing numbers that happen to contain many zeros. Now, the standard format for scientific notation looks kind of like this. Okay, so in scientific notation, some of the key things to note is that there must be one and only one number left of the decimal point. Okay, there can be an infinite number of digits after the decimal point, but there must be a number to the left of the decimal point, and it can't be 0. And there can't be more than one digit. Now, this number here, the exponent on the 10, is positive if the number is greater than 1. And this number would be negative if the number has a value of less than 1. I guess we'll put an equal sign, greater than or equal to 1. So let's look at some examples of numbers. This is an example of a number in scientific notation. This is not. Okay. This can't be a 0. This is also not. You're only allowed to have one digit left of the decimal. Okay, so when you put a number into scientific notation, or if you're asked if a number is in scientific notation, this is what you're taking a look at. Now, the value here can't be positive or negative, and it really can be any number. You can have as many numbers to the right of the decimal. You can have no numbers to the right of the decimal. So this is also okay. There's no decimal point, but there's nothing wrong with that. Okay, now let's look at putting a number into scientific notation. Okay, so we're going to convert this number into scientific notation. Now, the first thing when you're going to convert a number into scientific notation is you have to locate the starting point of the decimal. In a whole number, the decimal point essentially starts at the end. So I'm going to start here at the end, and I'm going to move the decimal point until there is one number to the left of the decimal point, and it cannot be a 0. So that means the decimal point is going to go from here, and it's going to end up here. Okay. Now, any zeros at the end, especially if they're not significant digits, will disappear. So remember, the point of scientific notation is to try to remove zeros from the number. Okay, so the numbers that are not 0 and that are still significant are going to stay. So that would be 3.65. These are non-significant zeros because there really is no decimal point showing in the measurement, so they'll fall off. Now I put times 10. Now I'm going to count how many places that I have to move the decimal to go from here to here. So that's 1, 2, 3, 4, 5 decimal places. Now the last thing I have to ask myself, is that a positive 5 or a negative 5? Remember, positive exponents mean the original number had a value of greater than or equal to 1. Well, 365,000 is obviously greater than 1, so this will be a positive 5. All right, let's look at another example. Okay. All right, this one actually has a decimal point in the original number. So it's going to start here, and I'm going to move it again so that there's one and only one number to the left of the decimal point. Now, all of these are significant figures, so they all have to appear in the final number in scientific notation. So now I'm going to write, now the decimal point's here, and then I put all the numbers after it. And now I say it started here, and I went 1, 2, 3. This is obviously greater than 1, so this is a positive 3. Okay, now here's another number. The decimal point is here. I'm going to move the decimal point until there's one number to the left that's not the 0. So the decimal point is going to end up right here. Now these are not significant zeros, so they're all going to vanish. Just leaving me 7.9 times 10. And I ask myself, how many decimal places? 1, 2, 3, 4, 5 decimal places. This number has a value of less than 1. So in this case, it's a negative 5 is the exponent. Okay, now let's look at this number. Here's our decimal point. We're going to move it until there's one and only one number that's not a 0 to the left. It's right here. So it's going to end up here. Now this is a significant 0. So this has to also appear in the number in scientific notation. Okay, and I want 1, 2, 3, 4 decimal places. This number is less than 1, and negative 4. Okay, so when you move the number, the zeros that disappear are the non-significant zeros. Okay, any number that's a significant digit will have to end up in the number. Okay, now let's look at numbers converted into what is not scientific notation. It's sometimes called standard notation. The way we're used to writing numbers is called standard notation. Okay, so let's look at so here's our number, and we're going to put this into standard notation. So we're going to ask ourselves, first of all, we're going to kind of go backwards. Do we have a positive or a negative exponent? This is a positive exponent, which means that this number, this whole thing, has a value greater than 1. So that means when we decide which direction do we move the decimal point, we're going to have to move it so that the value ends up being greater than 1, which means you have to move the decimal to the right. Now, when we're going to move the decimal, if we go 3 places, we still have 3 more places. So now when we move the decimal past, then that's where we go. We add the non-significant zeros back in. Okay, so this one goes 1, 2, 3, and then I have to add 3 more to get to 6. Okay, decimal points here, I have to add 3 more non-significant zeros to get it all the way out 6 decimal places to the right. Okay. So that means that this number is 8,113,000. Okay. Okay. So here's another number. Again, this is a positive exponent, so that it has to be greater than 1. So we're going to move the decimal this way. So this is 1, 2, 3 decimal places. So 9, 2, 0. We need another 0. So 9,200. Oops, sorry. All right, let's do okay, 6.15 times 10 to the negative 3. All right, so now we have a negative exponent, which means that this whole number is less than 1. Okay, so we have got to move this time. The decimal has to go to the left. So now we're going to move it. We're going to start here. So we're going to do 1. And we're going to have to, in order to get the other 3 decimal places, we have to add in the non-significant zeros. Okay, so there needs 2 non-significant zeros at the beginning, followed by the 615. You can always check yourself and ask yourself, okay, if I go back the same number, do I get? So I have to go 3. So I go 1, 2, 3. Would it be back where it started? So you can always check yourself. All right, one more quick example, and then it's time for you to do it yourself. Okay, so this is a negative 1, which means we're going to move the decimal, so the value of this is less than 1. It means the decimal point is going to go this way. Only 1 decimal place, so it's going to go right there. Now, this 0 at the end is a significant 0, so it has to stay in the final answer. This would be 1040. All right, now it's your turn to practice.